Thank you for joining. I'm Balaji, Baktha, founder and CEO of Ventana Micro. Ventana Micro was founded in 2019 with an intent to bring RISC-V to all high-performance applications. And since then, we've come a long way. As of last year, we've announced Veyron V2, industry's highest performing RISC-V processor, capable of taking on the other two ISAs in just about any high-performance application you can think of, right from data center, HPC AI, Gen AI, automotive, etc. So that's the background of the company. I'd like to invite my colleague, Travis Lanier. He's our Chief Product Officer on the stage with me. Travis has been in the industry for about 25, 27 years, doing processors his entire career, starting from AMD, then a dozen years at ARM, and another dozen years at Qualcomm, pretty much driving the forefront of the high-performance CPU strategy, planning, product definition, adoption, customer successes. So that's him. Delighted to have him with us for the past couple of years. So he's going to join me on the stage as we talk about the topic at hand today. So just to recap, Ventana has been a pioneer in driving RISC-V adoption in all of the high-performance applications with the introduction of Veyron V2 at the RISC-V Summit in Santa Clara. We also talked about how the RISC-V product line, the way Ventana puts it together, it's not only just the RISC-V processor, but bringing that together as a complete solution in the form of chiplets. We launched that at the last RISC-V Summit in Barcelona. The world has completely changed in the past 12 months. We all know what that's all about. AI. Even as we first founded Ventana, our founding vision was to come up with an architecture that will allow disruption of how compute gets done going forward. As you know, some of us have been involved with bringing ARM to the data center space and even x86 to the data center space. Having done those two things, why did we choose to do RISC-V? RISC-V brings some unique capabilities that are extremely well suited for where the world is going. So our presentation is going to tackle some of that. Next slide. On the heels of the successful product launch and bringing the most complete RISC-V platform to the market, we've had tremendous customer success. Ventana has progressed from being in the product development phase to more of a customer adoption phase. I'm really delighted to share with you that we have achieved that milestone in all major geographies. We have been able to bring Ventana solution to all major geographies. That's North America, Europe, Asia, Latin America. So if you go to any part of the RISC-V community, Ventana is extremely well known thanks to the work that we've done. So why is that? Yeah, I guess we go to the next slide. If you look at the computer architecture, the architecture that we've known all along has changed forever. Let me repeat it. The compute architecture that we come to expect and come to rely on over the past several decades has changed forever. The biggest agent of that change is the introduction of AI in every application that we could possibly conceive of. As we started thinking about Ventana's own journey, we had anticipated that such a change could come about. We didn't know it was going to be AI the way it does today, but we realized domain-specific acceleration is key. So if you look at the next generation architecture shift that I talked about, the biggest shift is we went from linear compute to more of accelerated compute. Accelerated compute is the key disruptor. AI is just an example, albeit a very big example of that concept. So AI is going to change everything we're going to touch, and the most compelling architecture that's going to enable that is going to be RISC-V, and Ventana has been investing in building a complete platform around this for 3 years, 4 years, and we're going to talk about the details of how that will be in the next few slides. Again, just to talk about the impact of AI. It's going to change the way a data center is put together. It's no longer going to be your compute where applications are doing the linear compute process is going to go out. You're going to have AI-assisted architectures taking hold. Copilots, predictive analytics in the form of models kicking in and doing the work, aiding your regular business applications to be much more efficient. So a lot of change is going to happen there. Automotive is going to be completely transformed by the introduction of AI. We all know that fully self-driving is just the beginning, but there are so many other things in terms of the physical infrastructure meeting the vehicles, optimizing how vehicles interact with the physical world, physical infrastructure. There's going to be a lot of AI there. Again, RISC-V can play a vital role, and Ventana's complete end-to-end solutions are being actively used in developing early versions of this by several companies globally. Intelligent edge. Everything that we've been thinking about, be it IoT, edge compute, et cetera, every one of them is going to change. It's going to become AI-enabled. So, what is this AI? How do you quantify it? Look at it. The impact of AI is expected to be to the tune of 22.5 trillion with a T. 22.5 trillion is the dollar value of quantified impact that AI is going to have in the world. Which means you can just look at every one of these applications. Each and every one of these applications is going to be completely transformed. For that, you need a different kind of architecture that allows you to take advantage of the shift. This is an opportunity for Europe to embark on this new architectural shift, leapfrog, and be able to get back into the semiconductor game in a big way. So, to kind of walk us through the nitty-gritties of what that is, I'm going to have Travis take over.
All right, let me see if I can get through the next few slides before they start playing the music really loud. All right, so some of the common pain points with current AI solutions. One of the first things that comes up is they're designed for yesterday's architectures. I can give you a long list of accelerators that were put out there to do ResNet, and they scored fantastic on benchmarks, but nobody's really interested in running ResNet anymore. So you need to be able to adapt to the changing workloads. And so today that's LLMs and transformers. That could change in the next couple of years. The other problem with the different AI accelerators is you need to be able to scale it to the type and size of the workload you need to run. And when you have a common ISA and a common, or the ability to modify what you have in there, you can make the right price point and the right performance for the workloads that you need. And then lastly, you need to keep up with the rate of innovation. So as we know, I just talked about how AI is changing very quickly. You need to be able to, A, have a common baseline, but you need to be able to adapt it quickly if something new comes up. So we feel that RISC-V is an obvious solution for solving a lot of these problems with AI, right? These first 2 points kind of go hand in hand. One of the problems with these AI accelerators is they all have their own ISA. So when you own your own ISA, that means you have to build your complete own software stack. So you have all these different startups trying to create their own AI accelerator. Then they're also trying to build their software stack and libraries on top of that. If you unify on what's common, then you can use the ecosystem to have a common ISA and be a software layer on top of that. And then the last 2 points go to what we just talked about. RISC-V enables you to adapt to changing workloads, so you can leverage that common base, but then modify it quickly if you need to. And then you can also have the scalability. So we feel RISC-V is a big portion of addressing this. Now, what Ventana brings to this right now is we have a high-performance platform. So next year, we'll be shipping our Veyron V2. This will be competitive with any of the latest from x86 or the ARM Neoverse type of processors. And this is a very high-performance platform. But that's one part of the solution. The other part is how do you actually accelerate for AI? So yesterday we had great presentations from Dynamics and Andes, and they were talking about, hey, how do you scale up and solve these acceleration problems on RISC-V? And they were talking about the vector units that you have for RISC-V and adding tensor or matrix operations to that. So we're calling that RUCA. We view RISC-V as the central place. It's a unified compute architecture. And right now we're talking about this from a data center perspective, but I worked in mobile for a long time, and we were always trying to accelerate various workloads. And when you put your little accelerators to the side, it's fine. You could do a couple of workloads, but then, all right, so you did that. How do you get the broader ecosystem to adopt that? So when you get this common ISA that's unified and standard, you can get everyone to port their workloads to that across a wide range of developers. The other portion of this is chiplets. So Ventana we're going to have an I/O hub partners that have solutions. We're going to have the compute server chiplet. And then what can happen there is you have a variety of acceleration types of chiplets that can plug into the solution. This gives you a scalable AI solution. Here we have an example where we're taking an NVIDIA Grace Blackwell and breaking that down into RISC-V equivalents. So here you can see you have a Veyron V2 RISC-V server. Then you have various RUCA chiplets for the AI acceleration. And you can put this together to create a complete platform for RISC-V. I talked about how software is one of the key points. And one of the advantages of RISC-V being open is that there's already lots of work being put into RISC-V to adapt the software to get it ready for these platform solutions. And in fact, Ventana already has various software stacks running on our platform right now. So we're testing out not just the pieces of it, but the complete stack running on the Veyron V2 and accelerating that for AI. So again, the main point here is Ventana is bringing a complete platform. We have the server base. We're working with the ecosystem to get the software ready. And all these AI applications can come together onto the Veyron platform. With that, I'll hand it back to Balaji to finish up the presentation.
There you have it. The point you should take away from that part of the presentation is RISC-V has unique capabilities that are extremely well suited to bring AI into the next generation compute architecture. As that compute architecture paradigm shift comes about, the tools needed to build the right solution for those markets are available in the form of complete platform. We're not talking about just core. We're talking about core, the CPU NOC, the chiplet, the I/O hub, 3D memory stacking, the entire software stack that goes with it. And on top of that, the ability for you to have your own custom acceleration capability sitting alongside the solution that Ventana provides. So you're not going to be limited by your ability to, or your desire to innovate. And so you're going to be enabled to do whatever you think you're going to have to do that's on top of what Ventana provides relatively easily. So that's the complete solution. And you can right-size that solution for various markets using chiplet-based architecture. The RUCA, RISC-V Unified Compute Architecture that we brought together, that Ventana has introduced, gives you the ability to take what RISC-V brings to the world. Open compute based on standards, no gimmicks. Everybody knows what that is. You can go build your own version of it, but then you can bring in, using the same vector extensions, matrix extensions, you can bring about your own version of that AI accelerator the way you see fit. Achieving all of this requires a complete platform. We told you we have that in place. And last but not the least, customers have been very positive. As I told you last week or 2 weeks ago, Calista and I have been in Latin America talking to one of the largest customers. Their interest level has been extremely strong. We've done similar work in Europe. I've been talking to all the major geographies, major sovereign nations here. As sovereign nations come to grips with the need of the hour, AI, your own sovereign data center infrastructure is what's going to set you apart from other nations. It's foundational for you to be successful as a country going forward. For that, you need to own your own AI infrastructure, your own compute infrastructure. If that can be done using an open hardware platform, and if Ventana can help in that vision, we are excited to partner with all of you. So that's the core message. RISC-V is here, not only to do legacy applications, but it provides you that compelling platform opportunity to enable the architectural shift that's upon us, aided by AI workloads. So that's where we are. Thank you so much for the opportunity. Please stop by. We have our senior leadership, Travis, as well as Mark Canal, here at the booth. We'd be happy to chat with you at length and answer any questions you might have. Thank you. Any Q&As, any questions?
Thank you, Balaji.